Hi everyone, AC7WH, Backyard Ham Radio. I want to talk today about the controversial topic of tuners, also known as antenna tuners, quote unquote, or trans matches. Now, I'm going to focus on how we can all agree, even if we may think that we don't agree. Let me explain. So when it comes to the big argument, the two sides where one says, yes, you can tune your antenna, and the other side that says, no, no matter what you do, you are not tuning the actual antenna. Why do I say that both sides actually agree even when we don't? Well, let me explain. Let's start with each individual component, and no, this is not going to be extensive. I'm not going to have fancy illustrations. I'm not going to do any testing right now with any antenna analyzers or oscilloscopes or anything. I have seen some great videos though about these topics, and I encourage you to check out some links down below for a couple of the videos or so that I have seen, but there are so many out there, and many of them have excellent testing procedures, great explanations from both sides. And the fun thing is, for me personally, I can find something that I agree with on both major represented sides. So let's explain a bit. So when it comes to an antenna tuner, we need to start by making sure we're on the right terminology. And when I say right, I don't mean there's a right or wrong terminology per se, although some things are easier to understand and construe the ideas more clearly. But let's talk about what we can agree on. So number one, if we start with the transceiver, the radio, we're going to be looking for primarily a 50 ohm impedance. That's the standard, of course. I would say most ham radio operators would say, oh, absolutely, that's the standard at this present time and for many, many years. Okay, 50 ohms, that's what the transceiver is made to operate on with the coax cable and so forth. Okay, so after that, there could be a number of different components, but let's focus on some major ones. Let's say after the transceiver, let's say there's an amplifier in there. Okay, that's connected by coax, let's say, typical standard installation. So after the amplifier, let's say where you're going to have the antenna tuner or transmatch or whatever you want to call it. And the antenna tuner contains some form of adjustable capacitor and some form of adjustable inductor. And then after the antenna tuner, let's say there is a length. I'm purposely being vague here, intentionally being vague. A length of coax, and then there is, let's say a balun or an un. And then after that is another certain length of coax, and then the radiating element, the antenna itself. Now that antenna itself may also have a loading coil at the base, in the center for a little bit better efficiency, or somewhere in between perhaps. Okay, so let's break this down. Since the transceiver is looking for 50 ohms, it's going to be happy, as you may hear in many videos. I'll just use that same terminology for convenience here. It's going to be happy when the signal coming in and out is at 50 ohms impedance. That way it sees apples to apples, so to speak. It's a smooth transition, almost like a manual transmission engine. Speaking of transmissions, a manual transmission engine with synchros. It's going to be a smoother shifting experience, generally speaking, as opposed to a mismatch in the revs and so forth. I know that's not a perfect illustration, but hey, I like cars too, so. Anyway, now, With that, as you introduce a new component to this, and I'm going to just go ahead and call it a circuit, an RF circuit, as you introduce each new component, there's a certain degree of loss, including any form of connection. So that can be the PL259, SO239 connectors, it can be an N-type connector, BNC type connector, any type of connector, there's going to be a certain amount of loss. It may be completely negligible so that nobody's ever going to hear the difference on the air, or it could be more significant, especially if you have one that's not good quality or that's old, corroded, whatever. But each time there is a connection, each time there is not only the connection point, but the coax or any other form of wires, cables, whatever, between point A and point B, there is going to be some loss that is introduced. Not only that, but there is going to be a certain amount of characteristic impedance that is being introduced. Maybe it's sticking with that same 50 ohms, or maybe it's going to be completely different, like ladder line, for example. It's going to have a totally different impedance, as I would think you all know. So, that being the case, we need to keep in mind that everything that we do to this RF circuit is going to have an effect. All right, let's continue on with our thought process. We've started with the transceiver. We talked about the 50 ohms. Now from the transceiver, we're going up to an amplifier. The amplifier is going to generally maintain something similar to those 50 ohms. And then from the amplifier, we're going to go to the antenna tuner. Now, I'm going to, for simplicity's sake, say that the transceiver and possibly the antenna tuner and the amplifier all have some form of like watt meter, SWR meter, and so forth in them, as opposed to it having a separate watt meter or separate SWR meter. So keep in mind, each of those things, if added separately, would have their own losses, could have their own potential effect, although minimal. But let's just use this example in this case. All right, so from there, when we have that antenna tuner hooked up in this illustration to the amplifier, now the antenna tuner is going to introduce capacitance or inductance or combination, generally speaking, and that, of course, is going to have an influence on the circuit. But let's go ahead and continue on through a length of coax. Again, being very vague here. And with that length of coax, we are now connected up to the radiating element. We'll say for this example, there is no separate coil involved, no capacitive hat as some antennas have, no tuning capacitor with the antenna like a mag loop antenna may have, as they are called. Just a straight up element. You could say a dipole, you could say a vertical, what have you. And now around that antenna, there are going to be a few metal objects, some house wiring, some gutters, some fencing, some chicken wire, maybe a metal gate, those sorts of things within a wavelength or so of the transmitted signal. And as I'm sure you all know, those things are going to be affecting this RF circuit as well. It's going to affect the overall resonance because of the capacitance or inductance or both that are introduced. That reactance is going to be affected. And of course, when you have metallic objects within a short distance, a small number of wavelengths, now you are introducing a different pattern to your antenna for the radiation pattern. So keep that in mind as well. So now we essentially have our whole RF circuit, including the ground and anything else that is nearby that could introduce that reactance, that capacitance, that inductance. And that's with a relatively simple setup. Yes, you could go even more simple, just straight up transceiver with tiny bit of coax over to the radiating element, but the general idea is still going to apply here. Okay, so now, hopefully you're still with me at 10 minutes. This is where I'm going to get to some of the main points here. I would say we can all agree that number one, no antenna tuner, quote unquote, is going to physically tune the length of the antenna. In other words, we are not going to be able to change the physical length of an antenna, making it longer or shorter. We are also not going to be changing the natural resonance of that antenna, where the antennas, the driven element, where the antenna's capacitance and inductance cancel each other out. For the antenna itself, the radiating element, we cannot directly change that as an individual unit unless we are actually lengthening or shortening the antenna driven element itself. I would say we can all agree on that, at least generally speaking. I would say we can also generally agree that when you have an antenna tuner, even though the antenna tuner can have a small amount of measurable loss, and there have been a number of tests done on this, for example, from the ARRL, and a number of excellent ham radio videos discuss these sorts of topics from what I have found. When you come to the antenna tuner, the biggest loss is the signal bouncing, to use that as an easy term, back and forth between the driven element, the radiating element, the antenna itself, and the antenna tuner, which basically is a mismatch to the impedance, if you want to get a little bit more technical. When the signal is coming back, trying to hit back into your radio, the tuner creates essentially a mismatched impedance going backwards so that it stops that radiated energy from hitting your radio, so your radio thinks it's a great 1.0 to 1 ratio, or SWR. And so therefore, because it's a mismatch, it sends it back to the antenna where it can be radiated, but a small portion comes back and all of that, dependent upon what the SWR difference is. Okay, so the biggest loss is from the coax. However, if you have high quality coax, even something like LMR 400, it's not the cheapest, it's not the most expensive, but if you have something like that, the losses, especially with a short run of coax, can be negligible. So if the tuner is losing very little radiated energy, and the coax is high quality coax that even with, let's say, 10 trips back and forth, where each time the radiated signal radiates a little bit more to the antenna and whatever's left loses a tiny bit in the coax, and then back up to the antenna loses a tiny bit more, and then a lot of that is radiated. If you figure all of that in, yes, there can be scientific measurements done for this, even some really nice, quite accurate to the real world calculations. It becomes pretty obvious that if the greatest loss is in the coax when you're using an antenna tuner, as long as you have high quality coax, especially a shorter length, there's not an awful lot to worry about when it comes to lost signal. So I'm not going to get into that too much right now, but let's talk about some other things that we can agree on. We can also agree that in a standard electrical circuit, whether DC or whether an AC circuit, which would of course be like an RF circuit, which is inherently AC, alternating current for the RF frequencies, obviously. If we think about a circuit and how if you add or remove any component, it's going to affect the entire circuit, I believe we can all agree that that circuit is going to be affected by any component. So let's take a regular electrical circuit for an example. Let's say we have a light bulb we have a resistor, we have a capacitor, we have an inductor, we have a battery for the power source, and of course the light bulb is the load. The primary load, of course, everything in the circuit is going to introduce also a load. The wiring, the resistor, the various electronic components, all of those have a load. Even the battery has a certain internal resistance to it. So we could get technical and deep dive into that, and I find that fascinating as well. I enjoy electronics, as I'm sure most of you do as well. So with that, if we think about how if you change any one of those components, it's going to affect the circuit in one way or another. For example, the light bulb itself. You can have a light bulb that requires a lower voltage or a higher current, or you could introduce a resistor that is a lower rating, so it's got less of an ohm resistance, or maybe less of a power handling capability. 1 watt versus 10 watts or whatever. All of those things are going to have an effect. Different rating on the capacitor, different rating on the inductor. For that matter, a larger battery. All of those things are going to affect the entire circuit because those items are connected. Yes, you can change out an individual item like the light bulb, which I'm sure you've guessed represents our antenna here. The light bulb, which radiates visible light and infrared heat, that very closely resembles an antenna. And so yes, you can change out the light bulb to have one that's brighter, maybe more efficient, etc. Just like you can change out the driven element, the antenna, the literal antenna in an RF circuit to get your desired results. Still, we must keep in mind that everything is connected in one way or another. Okay, so now I'm going to switch gears for a moment, and I'm going to talk about some things that may be a little bit more controversial, but if we think about all the things we can agree on, I would say that we may start seeing more eye to eye on this, but I also am learning from both sides. So every time I see a video from one camp or the other camp, I feel like I'm always learning something. And I hope that everyone continues that open-mindedness and isn't worried too much about semantics or terminology, but instead focuses on what is literally happening here and what are the goals that we have in mind. I would say for most of us, we want to be able to make those QSO contacts, and we want to be able to utilize the space and the finances that we have, and to be able to enjoy the ham radio hobby and to accomplish the communications goals that we have in mind. And I would say that's a great foundation. So, okay, here goes my controversial side. When it comes to an antenna and making it resonant, if you want to call it that, if we are talking about making the antenna resonant, again, the only way that I logically, from this foundation that has been laid, the only way that I logically see to make the antenna resonant or unresonant is to lengthen or shorten that antenna. Now, some of you may believe that if you take a coil, an inductor, or a capacitor of one form or another to tune that antenna, that you are also making it resonant, and that there is almost no difference, I don't know, between that versus just having the antenna resonant on its own. Now, I'm not sure how widespread that belief is. I would say, though, again, going back to what we can agree on, I would say we can all agree that an antenna that is at a quote-unquote natural resonant length is going to perform better than one that is extremely short, like let's say a 1/16 of a wavelength that has a large loading coil attached to the base of it or the center of it, whatever. Okay, so what am I leading up to here? So I believe, as near as I can see, with all the logical evidence that I've been presenting and with test results that I've seen, with a variety of perspectives, not just one camp or the other, not just a full-on bias or dedication to one side or the other side. But what I am seeing is that if we are thinking that a coil is going to help out an antenna and provide the desired results that we're looking for, well, guess what also has a coil? An antenna tuner. Now, what's the difference? The coils that are typically used in antenna construction are right either at the base or in the center of that antenna. So, what are we leaving out of the equation? That length of coax. And so really the only benefit from having a coil at the base of the antenna or center of the antenna is that we don't have the losses of the coax. But again, if we have high quality coax of a shorter length, if possible, in other words, if you can get by with 50 feet or 25 feet of coax instead of 100 or 200 or 300 feet of coax, then your losses are going to obviously be smaller. If you can use higher quality coax, then your losses are going to be smaller, etc. So in summary, I know I didn't fully finish this point, but these are some things that I'm thinking about and hashing out in my mind and kind of talking through as we go. So thanks for bearing with me. This is a road of discovery for me too, and I hope it is for each of you in one way or another. Even if you are an engineering genius, I hope that this is something that is at least helpful for a different way of thinking about all of this. Okay, so if you want to be able to use your antenna and make all the equipment happy, there's multiple ways to do it. You can have your inductor on or attached to your antenna, or you can have it in your antenna tuner. You can have your capacitor up at the top of your antenna as a capacitive hat, or you can have your capacitor inside your antenna tuner. Or you can have your capacitor, especially a high voltage capacitor, attached with your mag loop antenna. Or again, inside the antenna tuner, whether it's the internal antenna tuner of your transceiver or a dedicated antenna tuner that is inside your shack, or one with a short or almost non-existent length of coax right near the antenna, a remote antenna tuner, so you don't have as much of a loss as you would if there was a length of coax. No matter how you do it, what I am suggesting here is that each of these ultimately are the same thing. Now, what did I just do? I let out a big controversial statement. Yes, I did. So what was that again? I believe that whether you have your inductor or capacitor combination, your LC circuit, inside your transceiver with a built-in antenna tuner, or whether it's external but in the shack as a separate antenna tuner, or you have it as a remote antenna tuner mounted right below your vertical antenna, for example, or whether you make an antenna tuner as a hookup directly to the antenna in its individual components, like a capacitive hat and a loading coil at the bottom, something like you might do for one of the longer wavelength bands, like 160 meters, have that loading coil and have the capacitive hat. Guess what? You just made a form of antenna tuner. It doesn't necessarily make the antenna any better per se, but again, that's a very generic word, so I'm going to avoid that right now. But it has the effect of making the circuit work, that RF circuit work together, so that you are getting the best out of the materials that you have. Now, if you can have a full quarter wavelength long vertical 160 meter band antenna with 120 radials or whatever that are of the ideal length, and you don't have any metallic objects within multiple wavelengths because you have a large field and you have some of the highest quality coax and all of that, well, that's nice, but how often do you see that? Even on some of the smaller antennas like 40 meter vertical or 20 meter vertical, how often do you have no metallic objects within a wavelength? And if you do, remember that affects the capacitance, the inductance, etc., the overall reactance. So without going on too long here, as you can tell, I think that we can all agree on the basic ideas. I won't rehash those now, but the basic ideas of what component does what, and I think we can also agree on the fact that introducing any inductor, no matter how close or far away from the antenna it is going to have an effect on that RF circuit. And all of those effects are going to affect reactance and ultimately impedance. But the radiation pattern can also be affected with metallic objects. And keep in mind, if you are transmitting to an antenna that is less than ideal, you want to get as much power to that antenna as you can, obviously. So you want to have a good impedance match, and you want to have low loss cable, etc. So I could go on to like 5 different topics quickly here, but I see this is a very long video, one of my longest on this channel so far. But this is a topic that I am passionate about, but not passionate to just try to argue and butt heads. But a topic that I think we can all stand back and think, wait a second, we all do agree that this is what happens when you have lossy coax and you have a high SWR bouncing the radiation back and forth for the RF. We all can agree that inductors affect the overall RF circuit. Wherever they are in that RF circuit, there's going to be some form of an effect. We can all agree that an extremely short antenna is not going to have the same radiation of your RF as a nice long quarter wave or half wave or full wave antenna might have. All right, well, thank you everybody for watching. I hope this encourages you all to dive deeper and to think outside the box and to take just a moment to be a little bit quicker to stop and listen to others' perspectives. I'm not talking about mine personally, but others out there that may believe the opposite thing that you do when it comes to amateur radio topics, especially on tuners. And then a little bit slower to lash out back with negativity or arguments or just forcing one point over the other. Let's see if we can find out what is really meant by the terminology used, and see if we can see what we agree on rather than what we disagree on. And then using that logic, not that I claim to be the most logical person in the world by any means, but using that logic to think, wait a second, if A equals B and B equals A, then guess what? Somebody may like the letter A better, some may like the letter B better, but we're actually talking about the same thing. So that's what I'll leave you with for now, and thank you so much for watching. I hope this was helpful. This is AC7WH73.